In this question, we're posed the following scenario. A helicopter is flying in a straight line over a level field at a constant speed of 6.2 meters per second and a constant altitude of 9.5 meters. A package is ejected horizontally from the helicopter with an initial velocity of 12 meters per second relative to the helicopter and in a direction opposite to the helicopter's motion. The first part of the question asks us to find the initial speed of the package relative to the ground. So in order to solve this question, we'll take a look at this following equation. The velocity of the package relative to the ground is equal to the velocity of the package relative to the airplane plus the velocity of the airplane relative to the ground. So all we'll really need to do is to sub in our values here, but let's just take a look at the scenario. We've got the plane traveling in this direction and we've got the package traveling in this direction. So intuitively, all we really need to do is find this velocity over here. And that's what we really end up doing with this formula. We've got 12 if we consider this to be the positive direction and this to be the negative direction. 12 minus 6.2, which gives us a value of 5.8 meters per second for the initial speed. In the second part of the question, we're asked, what is the horizontal distance between the helicopter and the package at the instant that the package hits the ground? In order to solve this question, we are first going to list our givens. So the first thing we know is that the displacement in the y direction is negative 9.5 meters, since that is the altitude at which the plane is traveling. And the acceleration due to gravity, again in the y direction, is negative 9.8 meters per second squared. The initial velocity of the package in the x direction is 5.8 meters per second, and that's something that we figured out for part 8 of the same question. The velocity of the airplane is 6.2 meters per second. The velocity in the y direction of the package is 0 meters per second, since the package was thrown parallel to the ground. And in order to find the horizontal displacement, which is in the x direction, we'll need to first find out the time. So we know that we're going to have to use this kinematics equation here. We have 3 of the 4 variables. We know delta d, we know the initial velocity in the y direction, as well we know the acceleration in the y direction. So we've got d equals v1t plus half at squared. So all we're going to do is sub in our values, and then we're going to solve. And we get a value of t equals 1.39 seconds. You're also going to get a negative t value, but since you know that time cannot be negative, you can reject that immediately. So in order to solve the question, let's just take a look at a quick diagram of the situation. We've got the plane traveling in this direction, and we've got the package traveling in this direction, and we know that we've got 1.39 seconds for the plane to keep going this way and for the package to keep going this way. Remember that the horizontal component of the velocity is unaffected by the vertical component. So all we really need to do, since there's no acceleration happening in the x direction, is calculate d equals vt for both the package and the airplane. We can combine this into one equation, giving us d equals velocity of the plane plus the velocity of the package plus the velocity of the airplane multiplied by the time. So we get 5.8 plus 6.2 multiplied by 1.39, which gives us a value of 16.68 meters. And that's the horizontal distance between the helicopter and the package at the instant that the package hits the ground.